I think, Sebastian, you should be a presenter now, right? You should be able to unmute and...
Yes, perfect.
Welcome, Sebastian, and welcome to all the people attending as well. We'll just let the room fill up a little bit and we'll get started. Okay, welcome, guys. We'll give it to 2 minutes past and then we'll get rolling. Okay, so let's get started. Thank you everyone for joining this webinar, No Smart City Without Smart Metering. A bit of a bombastic title, but hopefully during this webinar we can give you an overview of how Smart City enables smart metering. We've saved the best till last. There'll be a live demo of an actual Smart City use case at towards the end of the 30-minute slot. So hopefully stick around for that and you'll actually see a smart city in action. So to kick off, first with an introduction from myself. My name is Adam Ray. I'm head of sales at LORIOT. LORIOT is a Swiss company and we build, develop and support a network management system that incorporates both a LoRaWAN and IoT network server. And effectively, we allow any company to build and manage an IoT network, a low-powered wide area network for all different types of IoT solutions. With that, I'll hand over to Sebastian to give yourself a short introduction.
Yes, hello everyone. My name is Sebastian Dörr. I'm from DIEHL Metering. I'm a solution architect. And DIEHL Metering is a German-based company, and we're producing mainly water and energy meters, and also some additional systems for connectivity and software systems to gather all the data. And back to you, Alan.
Perfect. Thank you, Sebastian. Yeah, so LORIOT and DIEHL, let's say, working together in two different aspects of the stack, which we'll go into later to help deliver a smart city. So what is a smart city? Well, you know, the typical definition is let's say, a technologically advanced city that's putting out lots of sensors to collect data about all different metrics and performance levels within a city, and effectively trying to take it from being a kind of analog or dumb city to a smart city. But how do you get there? Because, you know, the journey to becoming a smart city is not a simple one, but going from nothing to having something a little bit smarter is a massive improvement. And the kind of main, let's say, three performance indicators we're looking for when deploying a smart city is obviously a lot of time to improve efficiencies. So reducing, let's say, increasing traffic flow within a city, or reducing how much waste energy is used for lighting and for running costs within a city. But a lot of it is not necessarily driven towards generating revenue, but more reducing the waste and costs while operating a city itself. For creating kind of new services and business models, so improving kind of like how cities can deliver services to the citizens that live within there. For example, the transport system or the air quality within that area, how can that be improved? And many of the, let's say, benefits for a city to become smart are not directly related to purely economic benefits, right? Many of them are well-being and quality of life. For example, we mentioned like air quality, or the quality of the drinking water, or the waste collection being on time. The many areas where the actual well-being and happiness of the citizens can be benefited by understanding the city better. So to give you, let's say, a quick example before we jump into the metering side of things of some of those use cases. Here in the city of Lucerne, it's a very popular tourist destination. Every day, many buses arrive to the city. And of course, there's always the big struggle to find a parking space for those bus drivers. So they have to kind of go from one parking space, parking lot to the next until they find a spot. And the most popular is always closest to the best attractions within the city. But if we can give the drivers information regarding where spots are available, then before they arrive at the city using a application, they can see where there are spots available. And if you imagine cars spend probably around about 20% of their time actually driving and the other 80% looking for a parking spot or idling, just by reducing the time it's looking for a parking spot, if it even saves 10% of the emissions, it's a big win. And although in one day that might not be a lot of high value, but over a year and over many years, that all builds up. But it's not immediately evident, or you don't immediately get the return on investment for that use case. And it's not a big enough use case necessarily to stand on its own feet with regards to the infrastructure investment to build a network. A quality of life benefit, for example, might be monitoring the water quality within the areas in the parks or at the beaches. This can have obviously a big benefit for the well-being of the people who are swimming in those areas or visiting them, or recreational sports like fishing, but politically as well, right? It's you don't want to have poor quality water that's affecting people's quality of life. It doesn't go down well, let's say, within the community. These are all use cases effectively where we want to deploy them, but this single use case by itself, as I mentioned, doesn't quite justify the potential infrastructure cost. And this is where metering comes in, right? Metering is a big enough use case, can provide the value on its own legs to deploy that infrastructure. And on top of that, then we can start, once we've got the, let's say, infrastructure in place by this primary use case, which is metering, which is a large scale deployment, then we can bring in all the other types of solutions on that city. So we need to ask some questions like, who's going to manage the network? Who's going to build it? What does an actual network, a smart network and a smart city look like for a city? Sebastian, maybe you can help us with that and give us an idea of what smart metering really looks like at the ground level. I think you're muted at the moment, Sebastian.
Yeah, of course, Alan. Yeah, I prepared something for you. Yeah, let's start talking about smart metering. So at first we have a short definition of smart metering. So we need smart metering is the computerized measurement, determination, and control of energy consumption and supply. And companies and private households are equally relevant. We all know this. And smart meters are intelligent, connected meters for resources, energy such as water, gas, or electricity. With this in mind, we can take a look at our portfolio and what we need to do smart meter use cases, or to enable smart meter use cases. At first, we need the meters on the bottom, then we need the connectivity side and the software side on top. At first, we will start about intelligent meters. What makes a water meter, a heat meter intelligent? On our side, we see that we can collect very small measured values. Also, we can detect faults and manipulation in the meter. We have the formation of relevant measured values in addition to energy and volume in the meter, so additional values. And also we can have something like leakage warnings, pipe bursts, temperature information, and something like contamination information from the meter itself. We also just learned that smart meters are intelligent and connected. So the transmission technology is often very modular. We have different kinds of communication protocols that are available for different meters and different use cases. And the meters can, on one way, communicate via a gateway or directly to a software platform. Depends on the connectivity. On the gateway side, the gateways really do build the backbone of the low power wide area networks. They need to have enough power for the number of sensors we need for our use cases and our requirements in the use cases. They can filter sensors before forwarding the data to the software platform. And also, we have some gateways. They have different radio technologies that work simultaneously with one network, and we call these hybrid networks, and we will talk about them a little bit later. Then we have the cloud. There, the magic happens. We collect data, we provide the data, and the data transmission from the gateway to the backend systems happens in the cloud. We need enough power for data transmission. Usually we use LTE, 5G, or wired communication. Also private networks can be used, and the data is always encrypted in the cloud. And last but not least, we have the software platform. Here we have the decryption and the interpretation of the data. The data stored in the database, and this is the interface to other systems like billing systems. We analyze meter and sensor data in the software platform, and also we have the possibility to do some local installation as well as cloud applications. So the next part is the advantages of smart metering. So with smart metering, we can reduce losses due to the fact that we have regular balancing of our networks. Also in water meters case, we have the detection of leakages at the meter site. So also this reduces losses in the network. We can increase our efficiency by monitoring temperatures in district heating networks. We can control energy and resource outputs, and we can reduce volume flows in the networks. We also can optimize our purchasing because we have regular demand control. We have a consumption analysis. We can build our own load profiles for our customers, and we can detect or recognize additional feed-in into our networks, and we have a regular balancing of the energy and resources we have in our networks. This makes everything economically viable. We can save money on the meter readings by doing this automatically. We have more accurate measurements than with old and mechanical meters. We have fewer on-call assignments, which saves money, and we can increase our customer satisfaction. These are the advantages of the smart metering. The next step is, of course, the challenges of the smart metering. We have the network coverage, we have the antenna sites, the economic efficiency, and the performance. For the network coverage, we have to reach all meters and sensors. This is, of course, the most important point. Yeah, we have to get data from all the meters. Otherwise, we have to go to the meters and collect the data per hand. Therefore, we have to take the installation situation in account. So it's important to know if the meter is installed in the basement or just in the just above the street. Next point would be the antenna sites. We need to identify the areas where we have to build the antennas to have the best network coverage. Therefore, we have to approach the owners of the sites where we want to build antennas. We have to check the suitability of the sites, if we can build an antenna at an antenna area we want to use, and therefore we have to conclude rental agreements with the owners. Also, we have to be economically efficient. We have to optimize the number of antenna sites. We have to adapt the radio technology to our requirements and use cases. And Additionally, we have the smart city applications that we will like to run via our network, and we also have to take this into account. Therefore, the performance of our wireless technology must be able to process all the numbers of sensors and telegrams, and the performance of the radio network must match all the requirements we have from our use cases. So what's the solution to all of this? The solution, on the one hand, is the network planning upfront, and the utility should be the infrastructure operator. For the network planning, we need this to ensure the coverage. We have to consider the installation situation. We can guarantee that we receive all the meters that are in our network planning. We have a structured approach to the project, and we have therefore plannable cost for the whole project. For the infrastructure operator or the utility, these are new business areas for most of the utilities. You can provide the LPWAN networks for meter readings. They are already available for meter readings, and you can open your network for external sensors and create new business models with this. So you can offer something like data transfer as a service. You have a greater sensor diversity thanks to hybrid networks, as I already talked about it, like you're using LoRaWAN and IoT with the same gateway. And you can enable the smart city with the LPWAN network you built for your smart metering use case. And these smart city use cases will also generate additional sales and increase the return on investment for your smart metering use case. So that's for the moment from the smart metering side. Alan, please, would you take back the presentation?
Yes, thank you, Sebastian. So appreciate that overview. Okay, so let's have a look then a little bit at the actual network. I mean, at LORIOT, we love to talk about networks, and we believe the network that you build is a real enabler for smart cities and can kickstart it. One network to rule them all. I mean, obviously that will never be the case, but if we can create a network that adds a lot of value with many different use cases on top, then it could be the best network, maybe not the only one. So looking at the kind of the infrastructure perspective, it's one thing to deploy a network and to start building it out, but the other is how to scale and manage it. And the benefit for a utility or whoever is the infrastructure and network operator is that essentially you can have one single network management system. And within that system, as a hybrid approach, you can add your IoT gateways, your LoRaWAN gateways, or even, as Sebastian mentioned, a hybrid gateway, which has both technologies within it. And then we can leverage the pros of each technology for the suitable use case. So for example, with metering, we can put out the IoT gateways, but there's a very big ecosystem of LoRaWAN sensors and solutions out there that we can deploy LoRaWAN sensors throughout the city. And effectively, as a utility or an operator, you're able to manage and scale all these network and solutions within one single system. And at LORIOT, we have a platform in order to make this easier to manage, and we can host the server or deploy on premise in order to kind of help manage with the actual network itself. And the operator can effectively just focus on building out use cases and deploying new value for the citizens within the city. Why the hybrid approach? Well, there will be new technologies as well as LoRaWAN and IoT, and LORIOT will add new protocols. So you're future-proofing your network with new technologies that go on there, and the infrastructure investment you make can be leveraged and aggregated across many solutions, not just one solution. As the sort of owner of that network as well, you're creating independence for your city with regards to controlling and managing that network and not having to rely on a third party to build it out. And as Sebastian mentioned, there's many opportunities to monetize the network by reselling solutions that are built on top of that network, or reselling the network even to solution companies or companies that want to kind of build out services within your city. So there's a lot of benefits, and the hybrid approach effectively enables you to have all different types of use cases within the same infrastructure. And what we want to avoid is building many different networks with siloed data that requires you to manage them all, and instead just put it all within one centralized system. So shall we move on then, Sebastian, to have a look at the live demo? I think that's probably the juiciest bit of this webinar that people are interested to see. I will get rid of the presentation and then you can take over, yeah?
Yeah, of course.
Perfect. Oh, one thing maybe just before we jump in case we forget, we will both be at eWorld in February. So if anyone wants to meet DIEHL or LORIOT at eWorld in the beginning of February, then we'll be happy to meet there and just contact us afterwards and we can set up a meeting. Yeah, perfect.
So can you see my screen, Ella?
Probably just loading, 2 seconds.
Yeah.
Yes, looks good.
Okay, perfect. So what we're seeing here is a dashboard view on our ISO Plus portal. It's the software system we use to show our collect, interpret, and analyze metadata. This is our own DIEHL metering software solution. This dashboard is pretty much configurable, so you can build it like you wanted to. For this customer, we have some missing receiver analysis, so this looks pretty good. On this side, we're missing some. So this is the first overview of your network and your use cases and even different sensors if you want to. If you go deeper into the meter management, we can see we have an overview about all the meters we have in this software or in this platform. For now, we want to have a look at those CO2 sensors, as it is a smart city use case. We can check the data from all the sensors we have in the list. Just by double click, we can see the metadata, like where is it positioned, and we can have all the measurements, like the ppm of the CO2, battery voltage, the temperature, air humidity, and everything the meter provides. Also, we can have this as a graph view, and we can click in and out different information. If you go back to the browser, we also have the possibility to show the meters on the map. For example, if I like to have a look at these meters on the top left corner, so now I have them filtered. Oh, sorry. Then I can see that the last measurement was from May 2022, so nearly 2 years old. This is probably when they tested the sensors if they are working properly. And if you now want to know why don't I receive any meter data, then we have the possibility to add our network planning to the map. And if we do this, then we can see the meters are outside of the actual network at the moment. So everything that's green, yellow, and red is the network that's actually built by the customer. So we have the 4 antenna sites at the black markers, and you can see they're outside of the network. So that's why we don't see any live data from the sensor. If we go inside the network, like meters we see over here, there's data from today, from a couple of minutes ago, available. And yes, I think that's it for now with a short overview over our live system. And now we are open for questions and answers. Alan.
Thanks, Sebastian. Yeah, maybe I can quickly ask one. So effectively in this platform, you can bring in all the metadata, right? But you can add other sensors, maybe other DIEHL sensors, but also maybe other third-party sensors.
Yes, of course. So these CO2 sensors we see here are from, no, it's not, we don't have this this meters, but yeah, we're open
we
to
can't plug anyone's sensor.
Yeah, we are open to many manufacturers, and we can add additional sensors to the system. That's absolutely no problem. And we're also open about the technology you use to gather the data. So it doesn't matter if it's LoRa or MIoT or wireless ambers or narrowband. That's everything. Nearly everything is available, or we will make it available if a customer asks for it.
Nice. And can this, let's say, can the data also be fed into other systems as well?
Yes, we have a REST API, and we can adapt our interface to many other systems. Mainly, these are billing systems from our customers, but this is very adaptable to many different systems. There.
Okay, great. Well, we have one question from Hussein. Is it only LPWAN? Well, from LORIOT perspective, if you're building out the network and using our network management system to manage that network, then it is only LPWAN. You're building out a LoRaWAN and MIoT network, which are LPWAN networks. There's no device data coming in from any other protocols, let's say. But from your side, Sebastian, as you just mentioned, right, you can ingest data from any endpoint, let's say.
Yes, right. So we can, I think it starts with an FTP or SFTP where we can gather data from, or using the REST API or our own interfaces or the LPWAN network. So our system is pretty open.
Okay, and I guess if you have existing data points, right, or existing sensors out there that are not LoRaWAN or MIoT, you could bring that data also into the platform with your newly deployed network and sensors.
Yeah, of course.
Super. Okay. Then any more questions, guys, on the network or on the platform itself? No? Okay. Then yes, thank you, Sebastian, and for everyone attending. I guess the kind of core message of this whole webinar being that effectively, if you want to deploy smart cities, it does require infrastructure investment. It does require management, but smart metering can be that primary use case to deploy the network, and then an enabler for all the other use cases that a smart city deploy. And I think it's best to agree that the ecosystem for solutions that a city can adopt now has never been bigger. There's a whole wide variety of use cases. That's thousands actually out there across many different areas that could go on top of that network. Yeah.
So we have another question.
Yes, go for it. Yes. What?
Sorry,
Carolina asks. No, please. Carolina asks, what type of alarms do you use on your smart meters?
So obviously, it depends on the meter. If we have a heat meter or a water meter, and there are a lot of different alarms, like leakage alarms or temperature alarms for energy meters. Okay, so also there are different alarms for fraud or manipulation. If someone cuts the wires for a temperature sensor, this would be an alarm. Also, we have alarms for the wrong dimension of a meter. So if the meter is too small, you will get an alarm. Or if there's air in the pipe, this will be an alarm, and a lot of other stuff. So I think we have like 12 or 15 alarms in the energy meter. A bit too much to mention them all now. But we can of course give out some information afterwards.
Yeah, there's a lot of information, let's say what's happening with your meter out in the field, right? Because managing these things remotely is key to making sure that the ongoing operation costs and efficiency is achievable, let's say. Well, I hope that answers your question, Carolina. If there's any more, we have let's say another minute or two. No? Okay. Well, then I think that's, oh, Philippe is mentioning. There's your chance.
Everyone waiting for Philippe.
Advantages of IoT versus LoRaWAN. Well, we'd be happy to give you some information on that, Philippe. Definitely, if you contact us, we can send you some papers. It's a extensive, let's say, technical, and one aspect is the technical side, the differences, and there are differences on the two technologies, how they transmit their data. And then we can look at like the ecosystems of both protocols and what solutions are available to them. But maybe that's a topic for another webinar, right? We can do a IoT and LoRaWAN technical overview.
On the DIEHL side, we have something called CS Campus, and there we have a 2-day workshop explaining all the most recent LPWAN technologies.
Yeah. I think let's say our combined philosophy is that there's use cases that are good for IoT and use cases are good for LoRaWAN, and with a hybrid approach, you can benefit from both effectively. Good. Okay, then I hope that was a good overview for everyone. A nice, short and snappy webinar. And yeah, as mentioned, if you have any questions or you'd like to learn more, please follow up with us, and we'll be happy to give you more information. And yeah, thanks again, everyone, for joining the webinar. We hope you have a great rest of the day. And if you are at eWorld, yeah, let us know.
Yeah.
Perfect. Thank you, everyone.
Perfect. Thank you. Bye.